Travel from Earth to other stars is a common theme of many science fiction stories. Such journeys are far beyond the capabilities of current space technology, and using existing rockets or spacecraft would require many thousands of years simply to reach the nearest star. However, despite interstellar travel being currently impossible, in the 1970s, a very ambitious design for a plausible interstellar spacecraft was conceived by a group of designers and engineers who are members of the space advocacy organization, the British Interplanetary Society. The resulting plan was named Project Daedalus. Project Daedalus was a study carried out between 1973 and 1978. The goal was to design a robotic interstellar spacecraft. The requirements for the design were that it be based on existing or near-future technology and that it be able to reach its destination within a human lifetime. These guidelines ensured that the spacecraft would be practical and that those who worked on the project might live to see it achieve its goals, and that several stars could be targeted using the same type of spacecraft. The star selected as a destination was Barnard's star, a red dwarf star 5.9 light-years from Earth. At the time, it was thought that it had at least one planet. A travel time of 50 years was chosen, which would require the spacecraft travel at 12% of the speed of light. Reaching such a speed is far beyond the capability of current rockets. To achieve that velocity, the spacecraft was to be powered by a nuclear fusion rocket. The engine would be fueled by pellets of a deuterium-helium-3 mix and would operate on the principle of nuclear pulse propulsion, in which electron beams would trigger what would essentially be miniature nuclear explosions by detonating 250 pellets per second. The resulting plasma would then be directed rearward by a magnetic field, providing thrust. Helium-3 is scarce on Earth, but it could be mined from the Moon, although one plan entailed mining it from the atmosphere of Jupiter by balloon-borne robotic factories, building up the needed supply over a period of 20 years, obviously requiring a substantially advanced space-based industrial infrastructure in the future. The spacecraft would be massive, with a length of 623 feet and weighing almost 60,000 tons, and would need to be constructed in Earth orbit. It would consist of 2 stages. The first stage would operate for 2 years, propelling the spacecraft to 7.1% of the speed of light, and then would be jettisoned. The second stage would operate for 1.8 years, taking the spacecraft to 12% of the speed of light prior to being shut down. During the 46-year-long cruise to Barnard's star, the spacecraft would gather data on the interstellar environment and transmit that data back to Earth. The second stage would be equipped with 2 optical telescopes, each 16 feet in diameter, and 2 dish antennas, each 65 feet across, to be used as radio telescopes. 25 years after launch, the telescopes would begin scanning around Barnard's star for any possible planets. The data collected would be beamed back to Earth using the 131-foot diameter second stage engine bell as a dish antenna. The spacecraft would not decelerate. Instead, 18 autonomous probes would be carried and would be deployed between 7.2 and 1.8 years before the main spacecraft entered the Barnard star system. These sub-probes would be propelled by nuclear-powered ion drives. The probes would fly past their targets and their data sent to the main spacecraft to be sent back to Earth. The spacecraft would be protected from debris impacts by a disk of beryllium 7 millimeters thick and weighing 50 metric tons. Large debris in the path of the spacecraft would be vaporized by a cloud of particles spread in the path of the spacecraft by robotic vehicles 200 kilometers ahead of the spacecraft. And robots called wardens would also be carried to autonomously perform repair work. Project Daedalus was a thought exercise more than it was an actual proposal for an interstellar spacecraft. However, it is still very intriguing that at a time when robotic probes had just been sent to the outer planets of the solar system, there was a group of people seriously discussing ideas for exploration beyond the solar system, much further in the future. Obviously, the concept is very ambitious, requiring resources and technology that do not yet exist. On the other hand, the design obeys the laws of physics, and the technology and engineering described were extrapolations of what was known at the time, or at the very least, what was theoretically possible with more advanced technology. As advances are made in technology and space exploration capabilities, perhaps Project Daedalus or a similar spacecraft will become reality. Thanks for watching, and if you like this video, please like and subscribe. And remember, when the future was cool.